Once again, it's Mr. Laidan. Today we are going to look on the concept of dilution using alligation. Alligation, this is a means of calculating the percentage strength or the concentrations required of the given solution. So this is a quick method of identifying the final percentage strength or obtaining the required proportions of the solution or semi-solid preparation in order to get the final percentage strength of desired strength. So we have different kinds of alligation. Most commonly, we have alligation medial and alligation alternate. How are these two different? Alligation medial is employed when we have the known quantity and the known concentration. If you have the known quantity and the known concentration of the desired component, then we may quickly calculate the final percentage strength of the desired solution. So how do we do this? In medial, it is simple as this. The quantity of the component is multiplied by the concentration in terms of percentage strength, then you get the product. Thereafter, if you get the quantity times the concentration, you get the product P. Thereafter, take the products of solution 1, add by the products of solution 2. Maybe we may have many, 3 to 4. Then sum the products. This is P1 plus P2, maybe you get the total products. Then these are going to be divided to the total quantity, Q total, Q1, Q2, and whatever. So P total over Q total is going to give you the final percentage strength. And this is all about alligation medial. In alligation alternate, when you are looking at the number of parts, that's when we employ alligation alternate. So alligation alternate is all about the number of parts. If you are looking at the number of parts of different components of desired strength, then what we shall do is to obtain, to perform the calculation by using alligation alternate. And these are some of the examples regarding each. Follow me stepwise. So the question itself is going to tell you or to inform you which kind of alligation you are going to apply. Let's take an example of this question. In what proportion should alcohol 95% and 50% strength be mixed to make 70% alcohol? According to this question, we have different kinds of alcohol with different concentrations. Alcohol 1, let's name them alcohol 1. Alcohol 1 has got 95%. Then another alcohol has got 50%. Then we need the final alcohol. We need alcohol 3 here. What is the percentage strength? But alcohol 3, this kind of alcohol, the required one, the required alcohol should have the final percentage strength of 70. So 70% alcohol is the result of mixing alcohol 95% and alcohol 50%. But we don't know in what proportions exactly do we need to use to get 70% alcohol. So to know the proportions, which are equivalent to the number of parts, in this case, we need to employ alligation alternate because we are looking at the number of parts. What is the general rule of thumb when using alligation alternate? In alternate, you need to have at least 2 components, one with the higher concentration and one with a lower concentration, while the third is the required concentration. So in this sense, 95% alcohol is the one with the highest concentration. So highest concentration component shall be on the top. This is alcohol 95%, and the lowest concentration alcohol 50% shall be on the lower part, while 70%, which is the required concentration, shall be in the middle. Having done this, now you alternate as the name indicates. How do we alternate? This is like this. So you subtract. It's either 95 minus 70 or 70 minus 95. You get 25 parts. But these are parts of what? These are parts of alcohol 50%. Then you do the same on the other side. This is 70 minus 50 or 50 minus 7, and we have no negative in this sense. This is 20 parts of 95% alcohol. Having done this, from this point downwards, you are going to consider nothing but the number of parts obtained. So parts, we have 20 parts of 95 and 25 parts of 50%. So according to the question was about the proportion. In what proportion? So the proportions, the proportion simply means alligation ratio. So these are the proportions. They are going to be mixed in the proportion of 20 ratio 25. Let's check the next. Check the next question. Bullet number 3 states that what is the percentage strength, in bracket volume in volume, of alcohol in a mixture of 3000 ml of 40% volume alcohol, 1000 ml of 60% volume in volume alcohol, and 1000 ml of 7% volume in volume alcohol. Assume no contraction of alcohol after mixing. Now, according to this question, we're going to use a different kind of alligation. It's not alternate again. Instead, this is medial. Why medial? This is because we have the known concentration and quantity of each component to be used in our preparation. We have almost 3 kinds of alcohol. The first one, it has got, the quantity is 3000 ml with the concentration of 40%. Then the second one, it is alcohol with the quantity of 1000 ml with 60%. Then the last is also 1000 ml times 70%. As I said before, if you have the known quantity and concentration of each component, then you are going to use alligation medial. So if we multiply, this is 120,000 and this is 60,000 and this is 70,000. So this is 250,000 and this is 5,000. So as I said, to obtain the final percentage strength, take the sum of the product divided by the sum of the quantity. So this is equivalent to 250,000 divided by 5,000. Then what do we get here? And this is 50%. Remember, this was percentage, 50% volume in volume. So if you happen to mix these 3 kinds of alcohol with different concentrations, different quantities, the final percentage strength is 50% volume in volume, which has been obtained by alligation medial. Let's jump to the next example on alligation. Okay, let's check another example. We shall have about 4 more examples. So the next example is to prepare 500 ml of sodium chloride solution, 0.9% by mixing a 2% and a 0.5 sodium chloride solution. Now, we have got 2 stock solutions. And from those 2 stock solutions, we're required to prepare a single required preparation. What are these? We have sodium chloride. We have sodium chloride, which is a 0.9% sodium chloride. And also, we have another sodium chloride. We have another sodium chloride, which is a 0.5%. But we need we have sodium chloride, which is a 2%. We have a 2% sodium chloride and a 0.5 sodium chloride, but we require a third sodium chloride, which is of a 0.9%. In what quantity? 500 ml. So the trick is like this. We are required to prepare 0.9% with the quantity of 500 ml of sodium chloride, but in stock, on hand, we have sodium chloride 2% and we have sodium chloride 0.5%, meaning that we need to know the amount of each to be used in preparing the prescription. So this is not magical. How are we going to do this? How do we know the exact volume to measure from sodium chloride 2% and the exact volume to measure from 0.5% sodium chloride to prepare 0.9 of 500 ml sodium chloride? In this case, we are required to find first the number of parts of each. How do we get the number of parts? Then we are going to employ alligation alternate. Why? We have no known concentration and quantity. We have just the concentration, no quantity. So the principle is the same. We need to have the highest concentrated solution, the weakest, and the required one. So in this sense, what is the highest? That is 2. Then 2%, so we are going to use alternate here. 2%, that is the highest concentration. Then this is compared to the lowest concentration sodium chloride, this is 0.5, and the required one is 0.5. So we need to prepare, 0.9. We need to prepare 0.9 sodium chloride, then we alternate. There's one thing to note here. The required, during irrigation, the required concentration must be stronger than the weakest concentration of one of the components and must be weaker than the highest concentration of the components. So if you try to see here, 0.9 is greater than 0.5 and is less than 2%. In simple terms, the required amount during irrigation should lie in between the concentration of the components. So 0.9 is in between 0.5 and 2%. It should not be greater or less. Okay, let's aggregate. This is 0.4 parts of what? Of a 2% solution. And this is 1.1. This is 1.1 parts of a 0.5 solution. Okay, If you subtract here, you get 0.4, and if you subtract 0.9 from 2, you get 1.2. So in this question, obtain the number of parts. Okay, let's check the number of parts. The number of parts, we have 0.4 parts and 1.1 parts. And this is 0.4 ratio 1.1. So the total parts, this is 0.4 plus 1.1, and that is 1.5. To know the exact volume of a 0.5% sodium chloride to use, this is how we are going to do it. So if we need to know a 0.5, so from 0.5% sodium chloride, so amount from 0.5%. Consider the number of parts of 0.5%. So 0.5% has got 1.1 parts. Then this is 1.1 parts over total parts, which is 1.5, multiplied by the required amount. The required amount was 500 mils. So you multiply by 500 mils, then you will get the answer. So to know the amount to use from a 2% sodium chloride solution, consider parts of 2%, and these are 0.4 parts. 0.4 over total, which is 1.5, multiply by the total amount required, 500 mils, then we'll get the answer. Let us multiply. This is 1.1. 1.1 divided by 1.5, then times 500. This is 366 times 6.66. Then automatically this is 133.33 mils. So practically this means that you are going to measure 366.6 mils from a 0.5% solution of sodium chloride and mix it with 133.33 mils of a 2% sodium chloride solution. So after mixing the two, this and this, automatically you will get 500 mils with a 0.9% sodium chloride. Okay. The question says, how many mils of purified water must be added to 400 mils dextrose solution 30% in order to prepare dextrose solution 10%? Now this question can be solved in two ways. It's either by alligation alternate or by using the law of dilution. So because we are looking on alligation, we are going to use alligation method to solve this question. Then on the other time, when we shall be looking on dilution by using dilution law, we shall solve it by using the other way around. So what do we have in stock? In stock we have purified water. We have purified water. Then what do we have? We have 400 mils of what? Of dextrose solution, but with a concentration of 30%. What is the required amount? The required amount here is to prepare a 10% dextrose solution. Okay, so if in stock we have purified water and 400 mils of dextrose 30%, then we need to dilute dextrose from 30% to 10%. This is simple by using dilution law, but by using alligation, this is how it can be done. In fact, this is alligation alternate. If we alternate, we need to have the higher concentration, and this is 10%. No. This is 30%, which is in stock of dextrose, but also we have water. Pure water has got 0 concentration, and then we have 0%, and the required amount here is 10% dextrose. Upon alternating, this is 10 parts parts of 30%. Then if you take 10 minus 30 or 30 minus 10, you get 20 parts. 20 parts of 0%. Now what is 0%? This is pure water. Of pure water. After reaching this step, there's nothing to use except the number of parts. So considering the proportional, which is the alligation ratio, that is 10:20. Summing, the total is 30 parts. All right, so to know the amount of water to be added to dextrose so as to dilute the solution, this is what you are going to do. Go back to the data, then check this statement. You add 400 ml of dextrose, 30%. That is what is available. Okay? What do we do? So what we are going to do, here we had 400 ml, which contained 30%, but this was dextrose. Okay. So what we did before, we had dextrose, which was 30%, and we had 0%. Then the required was 10. Upon alligating, we had 10 parts of 30%, and we have 20 parts of pure water. So, meaning that 400 were in 30%. So if we consider the parts, this means that 400 was in 10 parts. So what about the rest of the parts, which are 20? Shall be contained in how many mils? And that is 2, and that is 800 mils. So after obtaining 800 mils, this means this practically, measure 800 mils of purified water. After measuring, add this into a previous solution of 400 mils of dextrose, 30%. Then stir well. After stirring well, that means your preparation shall be complete. It will automatically contain 10% dextrose solution, but with a total of 500 mils. Let's check another example. All right, as I said before, you may have 2, 3 or more stock solutions requiring to be mixed to make a single required solution. So if you have noticed before, we have been using 2 stock solutions. In this sense, we are going to have 3 stock solutions and maybe 4 stock solutions to make one. So if you have 3 or 4 stock solutions required to make one, how do we get the proportions? And what do we do in order to get a single required strength? The next question is about zinc oxide. Zinc oxide ointments. We have 3 different kinds of zinc oxides in the laboratory, each with a different percentage strength, and we need to consider them to prepare a single percentage of zinc oxide. So we have got zinc oxide containing 50%, and we have got another zinc oxide containing 20%, and the last zinc oxide containing 5%. Together should be mixed and prepare 10% zinc oxide ointment with a total amount of 150 grams. But according to this question, we only need to know the proportion. After knowing the proportions, other issues can follow. So how do we do? In this sense, we have got 3 stock amounts in the laboratory, not just 2. Remember, alligation, we may have 2, 3 to 4 stock solutions to make one. So in this sense, arrange them chronologically according to the principles of alternate. We need to have the highest concentration, which is 50, the lowest, or the second highest, and the lowest, which is 5. Then the required is 10. Then if you have got 3 ingredients, you need to alligate them to get the 4th. Then you may have 2 pairs. Then alligate the first highest with the lowest concentration. Then after that, you need to cross the second highest and the lowest. So what are you going to do? Start with 50 and 5%. This is the topmost and this is the lowest. Then alternate with 10%. Then 50 minus 10, you get 40. You get 40 parts of what? Of 5%. Then 5 minus 10, you get 5 parts. Get 5 parts of 50%. Then we are done with 50 and 5. What follows next? This is 20 and 5. So 20 and 5 are going to be plotted against 10. This is equivalent to saying like this, as you can see here below. So let us do it quickly. If we alternate 20 and 5 against 10, then 5 minus 10, then that is 5 parts of 20%. Then 20 minus 10, that is 10 parts. That is 10 parts of 5%. You can notice that 5% has repeated itself. Then you can sum up the parts in one part. Then you may have 10 parts plus 40 here. You get the total parts of 5%. So you may just add 10 here and have 50 parts. 50 parts of 5%. In this sense, consider the number of parts. This is 5 ratio 50, or 1 ratio 1 ratio 10. And that is a proportion. That is a proportion in simple ways. All right. So let's assume we were looking for the amount of each ingredient to be used. So to obtain the amount of each, you need to find the total parts first. So what's the total parts here? It's 5 plus 5 plus 50, then these are 60 parts. Having obtained the total parts, then we are going to obtain the amount of each kind of zinc ointment to be used. All right. Okay. To get the amount of 50%, zinc oxide, then consider its parts. 50% zinc oxide has got 5 parts. Then that is 5 parts of a total parts, which is 60 times the required amount, which is 150 grams. Then that will give you the actual amount of zinc oxide, 50% to be used. Then amount of 20% zinc oxide to be used in this preparation. 20% has got also 5 parts over 60 times 150 grams. You're going to get the actual amount. Then lastly, amount of 5% zinc oxide to be used. Check the number of parts. These are 50 parts over 60 total times 150 grams. Then this will give you the actual amount of zinc oxide. If you sum them, meaning after mixing them in a mortar and pestle or another device, you get the final percentage strength of 10% with a total of 150. Let's proceed with the next question. This is a very simple question. Calculate the amount of dextrose in 200 ml dextrose solution, 32% weight in volume. So we have the dextrose solution. We have dextrose solution with a total amount of 200 ml. And the concentration of 32% weight in volume. So the question is about calculation of the actual amount of dextrose. We need the actual amount of dextrose. Amount of dextrose in grams. So how do we get the actual amount of dextrose? This is very simple. If you have the percentage strength here of dextrose, 32 weight in volume, this is percentage weight in volume, 32 percentage weight in volume is equivalent to this. This is to say 32 grams weight in terms of grams are in 100 mils. So volume here represents 100 mils, and weight in terms of grams represents 32 grams of dextrose. So if 32 grams are contained in 100 mils, then what about 200 mils of the total preparation? Or in other terms, 200 mils of dextrose solution shall contain how much dextrose? Then this is equivalent to 64 grams. If I'm not mistaken, this is 64 grams of dextrose. So this is the actual amount of dextrose. Okay, quickly let's solve the next question. Next question. We're going to look on the percentage strength of an ointment which contains 1.5 grams benzoic acid in 30 grams of the preparation. So we have an ointment, and this ointment contains the following. It contains 1.5 grams benzoic acid, but the total preparation of ointment is 30 grams. So the required here is a percentage strength. So if you have 30 grams of an ointment, then it is made up of 1.5 grams benzoic acid. The final percentage strength can be obtained as follows. This is simple. This means that 1.5 grams of benzoic acid were in 30 grams of the total preparation of the ointment. Then how much percentage is contained in 100%? Okay, then this is 150 divided by 30. Okay. This is 5%. So this is equivalent to 5%. But this is not just percent, but percentage weight in weight. Why weight in weight? This was an ointment. Benzoic acid in terms of powder, and the ointment base in terms of powder. This makes weight dispersed in weight. So the final percentage strength is 5% weight in weight. Okay, let's quickly check the next question. This is a quick revision. Okay, now let's go back to alligation medial. There is this tricky question. It says, what is the percentage strength, volume of alcohol in a mixture containing 500 ml of terpene hydrate elixir, 40% volume alcohol, then 400 ml of theophylline sodium glycinate elixir, 21%, then alcohol, and sufficient simple syrup to make 1,000 ml. Remember, I said before, we only use alligation medial when we have the known quantity and the known concentration. Then we need to find the final percentage strength. So according to this question, what do we have in the lab? First, we have got terpene hydrate elixir. In what quantity? 500. So we have 500 ml terpene hydrate elixir with what concentration? With 40% volume in volume. Then what else do we have? We have 400 ml of what? Of theophylline sodium glycinate elixir with a concentration of 21%. Then we have sufficient syrup to make 1,000 mils of solution. So here, this was terpene, elixir, and this was theophylline. Then we have sufficient amount of syrup. We have sufficient amount of syrup here, which we don't know, to make a total of 1,000 mils solution. So, if you need to know the amount of syrup, which this is to say 500 plus 400, making a total of 900. Then 1,000 minus 900, you will get 100. You will get 100 mils times syrup. The concentration of syrup in this sense, this was 0%. So, because this was the base of the vehicle of the oil preparation. So if we tend to multiply here, if we multiply here, because in medial, you take the quantity times the concentration, you get the product. This is 500 mils times 40, then that is 20,000. Then 21 times 400, that is 8,400, and this is 0. Then what do we get here? This is 28,400. Remember in medial, after getting the products, you sum the product and get the answer. Then you sum the quantity here and get the answer. To know the final percentage strength, you take the sum of the product. This is 284,000. You divide by the sum of the quantities. Then this is 28.4 percentage volume in volume. Then that is how to go about that question. Okay, let's have more insight on the last two questions. Last two questions on alligation. Last two questions on alligation. Okay, the question states as this: how many mils of a 0.05 potassium permanganate solution must be added to 135 potassium permanganate solution, 1.5%, in order to prepare a 0.5 potassium permanganate solution? So, what does the question need? We need amount of potassium permanganate solution to be added to a certain amount of potassium permanganate solution to make another amount of potassium permanganate solution. So in the lab, what do we have available? We have potassium permanganate 0.05%. Then we have potassium permanganate 1.5% with the total amount of 135 mils. Okay. Then the required potassium permanganate should contain 0.5%. Now this is simple to go about. In your lab, you have two kinds of potassium permanganate. You have potassium permanganate 0.05%, and then you have another potassium permanganate 1.5% with the quantity of 135 ml. So the question is, how much from this potassium permanganate 0.05% must be drawn and added to this kind of potassium permanganate to produce a third potassium permanganate of 0.5%. Then if we are lacking the quantity and we need the number of parts, then we need to employ alligation alternate. Okay, how do we alternate? The general rule of thumb states you need to have the higher concentration from the available stock. The higher is 1.5%. Then the lowest is 0.05%. Then what do we need is 0.5% potassium permanganate. Then just alternate. 1.5 minus 0.5, this is 1 part. This is 1 part of a 0.05% potassium permanganate. Then 0.5 minus 0.05, this is 0.45. This is 0.45 parts of a 1.5 potassium permanganate. From this point, consider just parts. Remember, we have been asked how many meals from here to be used. Now go back to your data and find the statement with both quantity and concentration. The statement with both quantity and concentration is found here. In potassium permanganate, 1.5% with 135 mils, meaning that 1.5% was contained in 135 mils. Now check the number of parts of 1.5. 1.5 has got 0.45 parts. Then let's consider its parts. Then this is equivalent to say this is 0.45 parts were in 135 mils. Then what about the rest of the part? What about 1 part? Okay, then this is 0.45 divided by 135. Sorry. This is 1 part here. Then this is 1 part is equivalent to how many mils? Then this is 135 divided by 0.45. You get 300 mils. Practically this means that 300 mils of 0.05 potassium permanganate shall be measured, then mixed with 1.5% 135 mils, then making a total of 435 mils with a final percentage strength of 1%. Our final and last question on alligation. Okay, the final question shall be on a manufacturing pharmacist. A manufacturing pharmacist has got 4 lots of ecthermal ointment containing 50, 25, 10, and 5%. Then, how many grams of each must be used to prepare 2,800 grams of 20% ecthermal ointment? This was a manufacturing pharmacist with 4 lots of zinc. So we have got 4 lots of zinc. So zinc, there was a certain zinc ointment which had 50%. Then we had another zinc ointment which had got 25%. Then we had another zinc ointment with 10%. And the last zinc ointment with 5%. So from these 4, a manufacturing pharmacist needed to prepare a 5th one which contained 20%. So required, he wanted to prepare 20% in a certain amount, which was 2,800 grams. So in fact, this manufacturing pharmacist needed to prepare 2,800 grams of ecthermal ointment. Sorry, this was ecthermal. Let's make it good. This was ecthermal ointment. Ecthermal ointment. Then you want to prepare ecthermal ointment 2,800 grams with the final percentage strength of 20%. So if you have got 4 kinds of ecthermal ointment in stock, what do? You need to alligate, find the number of parts by using alligation, alternate. How do we do this? You may arrange your concentration according to the rule of thumb. Start with the highest to the lowest. Thereafter, choose the pairs. Okay, the highest is 50%, second highest 25%, third highest 10%, the last is 5%. Then the required is 20%. So we are going to alternate this, but it's hard to do this. What you are going to do, because you have got 4 components, choose just 2 pairs. Each pair should correspond to the guidelines and the rule of thumb of using alligation alternate. So we are going to choose 2 pairs in such a way that the required final percentage strength of 20% can be found in between. Remember, the required percentage strength should not be lower than the lowest component, or should not be higher than the concentration of the highest component. So if we decide to choose 50 and 25 and cross it with 20, then that is okay. Then if we decide to check 10 and 5, it is not okay, because 20% is greater than 5, it's okay. But also 20% is greater than 10. Then we cannot find the final percentage strength of 10 in between. So choose any pair corresponding to that principle. Okay, let's try to choose. Okay, the first pair may be maybe 50 and 5. Yes, maybe 50 and 10, 25 and 5, 50 and 10, 50 and 25, 50 and 5. All right, we may decide to choose 50 and 5. That is the first pair, because in between 50 and 5, 20% can be found. 20% is greater than the weakest component, and 20% is less than the strongest component. Then the second pair shall be 25 and 10. Okay. So 20%, which is required, is greater than the weakest concentration of the component, and 20% is less than the greatest component here. Thus the answer shall lie in between the required concentrations. So 20 minus 5, this is 15. This is 15 parts of 50%. And that is 30 parts of a 5% ecthermal ointment. Then this is 20 parts of a 25% ecthermal ointment. And this is 5 parts of a 10% ecthermal ointment. So up to this moment, already we have the parts required. So the total number of parts, we have 15 ratio 30 ratio 20 ratio 5. This can be written in an ascending order from the lowest to the highest. But obtaining the sum here, this is 15 plus this, so we have 50, and that is 70. We have a total of 70 parts. So let us prove our answer if it is really okay. 50, that is 30, and 5, that is 15, that is 5, then this is 10. Okay, this was wrong here. This is 10. So here we have 10 and this is 60 parts. So the sum of the parts is 60. The proportion of this ointment shall be 5 ratio 10, ratio 15, ratio 30. They're going to be mixed in that proportion. But in order to know the amount of each kind of ecthermal ointment to be used, you have to consider the number of parts. So if you need to know the amount of ecthermal ointment 50% to be used, then consider the number of parts of 50%. Number of parts of 50%, these were 15 parts. So we have 15 parts over total parts, which were 60 times the required amount. This is 2,800 grams. Get the answer. To know the amount of ecthermal ointment, 25%. 25%, where is it? Here it is. The number of parts were 10. Then these were 10 in 60 times the required amount. You get the amount to be used. 10% ecthermal, here it is. 5 parts in 60 times 2,800. You get the amount. The final is 5. The 5, which is 30 parts in 60 times the required amount. Then you will get the amount of each. Mixing both in a mortar and pestle, you will get the final percentage strength of 20 with the total amount of 2,800. So that is how you can go about this kind of alligation of 4 proportions. Thank you. Let's meet in the next session on dilution.